Hello, greetings, programmers. Welcome to TCoffeeAndCode, connecting to the Internet of Things. This is Jim McKeeth, and welcome. Yes, the warranty disclaimer. Again, I'm not going to read the text that's on there. Basically, this is a casual conversation, and buyer beware. I don't know. Do your own research, and hopefully you learn something. But who knows? Upcoming TCoffeeAndCode sessions on the 16th. We have data visualizations revisualized. This is to make up for the one that went poorly last time. A lot of great content there, just didn't, unfortunately, technical issues. Then after that, we have real-time streaming and message queues. On the 30th, we have working with the Apple M1. So I actually have the Apple M1 sitting right here. Actually, it's right here. And I've already got 10.4.2 running on it and stuff, so it should be interesting. I'm going to have, my goal is to have some content and some videos published before the 30th so we can talk about it and ask questions, and I'll have the device running and do some testing on it right there live as well. So that should be lots of fun. Robert's asking how my nose is doing this week. The world wants to know. It's actually doing a lot better. I got this, I went to the drugstore and got this stuff that's called liquid bandage, I think, and it smells like fingernail polish remover. And you paint it on with like a bright paintbrush, like fingernail polish, and it stings, but seems to do a really good job helping things heal faster. So after that, Docker containers and platforms as a service, and my key is coming off my keyboard. And then blockchain, NFT, and more to come. So stay tuned, and we'll hopefully see you around for more of those. So joining me today is the amazing Ian. I'm not sure where he's at relative to me, but Ian, you want to go ahead and introduce yourself really quick?
I'm that way. Hello, everybody. You've come across me before. I'm an Embarcadero Delphi MVP. Write code every day. Do a lot of talking, narrating, etc., etc., etc. You've probably seen me a few times on these if you follow along on TCoffeeAndCode. I don't know what. Oh, and I'm moving house today. So if we can make the webinar last 6 hours, my wife will have packed everything, and then I won't have to do anything. So the longer we can go, the better. Okay. I may have a divorce at the end of it, but that means I don't have to pack. That's fine. Yes.
Yeah. I understand but I don't want you to be a single guy. I guess that's your choice.
Yes, yeah.
And then the amazing Miguel. So both, actually, you and Miguel have been fairly regular on here. I appreciate that. I know a lot of other MVPs would love to be on here more, but it's a big commitment. I understand that because everybody's busy. Chris is saying I should have got some red coloring to put on my nose. Yeah, actually, I might get some LEDs and so it could glow. Miguel, you want to introduce yourself really quick?
Sure. Hi, everybody. My name is Miguel Moreno. I'm an electrical engineer by training. My main focus is in developing and integrating and designing embedded systems, which now all of them are under the umbrella of IoT. Also some integration systems and interfaces on board. Software developer, which nowadays you cannot design any electronic thing without going digital, meaning having a microcontroller at the very minimum. So my top languages is Delphi, of course. Then in descending degree is C++, assembler, Python, and MicroPython. For those that are not aware, there's a MicroPython version for microcontrollers, and has been taking off in the last years tremendously. So nowadays it makes it much easier to make embedded systems with MicroPython. For those that want to ask, yes, there is I would like to have a micro Delphi for microcontrollers. There are some alternatives in the time being, but still keeping my dream open that we will have a micro Delphi soon.
I think I saw somebody had an Object Pascal for microcontrollers, wasn't there?
Yeah, there is. Actually, FreePascal has versions for all microcontrollers. FreePascal, but I want the real Delphi for microcontrollers.
Yeah, I get that.
That's my take. But yes, to answer your question, FreePascal has been ported. For those that know the acronyms, Delphi runs over an operating system, be it Windows, macOS, Android, whatever. So It's on top of a foundation provided by the operating system. For those major operating systems, Rat Studio and Delphi already gives you this multi-platform development. But in embedded systems, there's still the old school of going bare metal. And bare metal means no operating system. You are directly coding to the microcontroller. For that option, we don't have a pure Delphi solution yet, but there is some ports of FreePascal to run on bare metal. Means with some support libraries in the compiler, you can directly compile into the microprocessor.
Yeah, and so that's actually people sometimes ask, what's the difference between Raspberry Pi, a single board computer, and a microcontroller, Arduino, the two
Correct.
And the operating system is the key, right? So
yes,
microcontrollers are real-time systems. They do one thing, and all your code, whatever code you wrote, is what it's doing. I mean, there is some low-level like BIOS type, I guess, that handles the I/O, but all the functionality-wise is all written by you.
Or borrow for libraries that you get from your vendor or whatever. But to phrase what you're saying, which is true, is you don't rely on operating system to do those basic functions for you. No, you need to add them either yourself by using a standard library, or you coding it yourself. But you cannot rely, like in a normal computer, that all these low-level thing is automatically done. You don't need to worry. No, in here you must schedule it, add them, or integrate it somehow.
It depends. It depends on the device, of course, as well, because the trend for a lot of the more consumer type of devices, there's much more of an operating system around, even if it's some bizarre hybrid like Fire OS or something like that, which I suppose that sits as an operating system for an Internet of Things device, but it's a bit tenuous to call it an Internet of Things device, because it's a thing on the internet. Yeah, but it's a little bit more focused than most. Amazon are pushing purpose,
Yeah. Actually, I'm gonna go ahead and go on to. Oh, I guess I have to introduce myself. Jim McKeeth, Chief Developer Advocate for Embarcadero, a longtime software developer. My claim to fame is I have a patent for swipe to unlock, the technology behind swipe to unlock and pattern unlock. I don't get money or Christmas cards for it, but I get to put it on my slides. I love development, technology, everything along those lines. Great stuff. So this is a Q&A discussion. Hopefully you all know that. Put your comments in the questions in the question panel here, and we'll discuss those and possibly answer them. And we're willing to answer in a "that's a good question, let's find out" way, and go down a rabbit hole. And wherever this goes, the conversation goes. So I want you to think of this as a casual conversation. Have a beverage handy if you can, and join in the conversation.
I want to point out I have 2 beverages available just in case.
Actually, I do too. I have my water jug.
Yeah, I haven't quite sunk to the hard beverages because it's the wrong time of day for the Americans, but maybe the rest of the world is sitting back with a gin and tonic or something. I don't know. TCoffeeAndCode and gin and tonic. That would probably get a lot more people joining in.
Gin and tonic.
Actually, I'll share a funny story about beverages. I'm not a drinker. Don't drink alcohol typically. I was in Australia a while back, and we get there the first night. We go out to eat, and they're like, "What do you want to drink?" I'm like, "I don't know. I usually drink water, honestly, most of the time." And they're like, "Oh, you gotta want something." You go, "How about a lemon lime bitter?" And I'm like, "What's that?" And it's pretty good. It's kind of sweet and a little, tart, and and I'm like, "Oh, sure, I'll give it a shot. I'm always willing to try something." So they give me a lemon lime bitter. I'm like, "Oh my goodness, this is amazing." So then the next day we had the big presentation, and I'm getting everything set up, and they're like, "Hey, can I get you anything, while you're getting ready?" And the person organizing the event, I'm like, "Yeah, can I get a lemon lime bitter?" And they're like, they look like, "What, really?"
Oops.
Turns out technically a mixed drink, but it has like a very minuscule amount of alcohol in it. Although there are soda versions that are non-alcoholic. And I didn't know that. And then the last day I was there, I went out to eat and I ordered a lemon lime. I was at a nice little restaurant and I ordered a lemon lime bitter. And it comes out and I'm like, it smells a little bit like alcohol. And I took the drink and I could feel it. And I'm like, I get out my phone and look it up. And I'm like, oh. So I never got buzzed like that. But
if you ever want to make yourself feel good about having a tiny amount of alcohol, you should read about Hunter S. Thompson, the author, very famous author, and his alcohol consumption. I mean, and actually illicit drug consumption as well. But how that guy managed to function at all is incredible. But I don't recommend it for anybody doing any presentations because I don't think you'd get very far. You'd start seeing Internet of Things in rainbows and stuff like that. Yeah. Someone asked us a question on the question saying, is there a summary of the content for the upcoming sessions?
Yeah.
Which the answer is we're chatting, really.
With the list of upcoming sessions. And yeah, that's a good idea. Let's discuss that. So data visualizations is, actually, I'll let you take that one, Ian, because you know a whole lot more about those than I do.
Yeah, well, yes. The last one was Jim wasn't available, and so I was driving the desk, and something horrible happened to the audio. And we think we narrowed it down to some kind of Bluetooth update. We think that's what happened. And so mine was working fine because I was connected directly into my computer, but David Intersimone, or David I, as everybody knows him, and I think, I've forgotten his name now. It's from Steamer.
Yeah, I knew his name until you said that, and I'm like, I can't remember either.
Yeah. Oh, I'm so apologetic to him because I do remember his name. It's just you know, moving and packing and all the other things, driving backwards and forwards to a lakeside house. But basically, we had to reschedule it. And so the idea was we showed David had a lot of slides and some presentations about visualization of data. So the whole point about that webinar was different ways to take data and then make it more palatable to people rather than just tables of numbers and figures. It's all about doing dashboards of information presented. And actually during the pandemic, we're all getting used to seeing different gliding slopes of data and things like that. So the data visualizations, that Steamer will be there again, and so will David I. And so next week, pop along and I'll be there as well. So we'll chat about visualizations.
I should be as well. It should be good stuff. Just yeah, exactly the way to visualize data. I saw this really fascinating system information dashboard today. Actually, I love dashboards, and there's a number of things I'd like to build some useful dashboards around just monitoring data and seeing what's going on. Although there's a on my slides, it had I mentioned that I built the brain-controlled drone, right, which is use the EEG, wireless EEG headsets so people could fly drones. And so that's something I've always been interested in as well. And there's I was reading a book, and they're talking about this stuff thing they're doing where they're building augmented senses for people, where the most common thing they're doing, generally speaking, is they have these little haptic vibrating motors like you'd have in your smartphone, and they put them all over your back, and the intensity and the pattern of the vibration and which motor is vibrating is tied to different data. And what they found is your brain can learn to understand this data, even if you consciously don't know what it is, your brain can eventually learn to understand the data. And
they put them on your back. Yes. Yeah, you know that's going to get abused. Vibrating haptic controllers. Yeah.
But actually, they did have the astronauts in the spacesuit. They have little things in there so that when they're holding like a screw, they can feel the screw through the glove, through the special sensors. But anyway, I was talking to a friend of mine that works in cybersecurity and realized that you could have a vest you wear at work that can have all these motors on your back, and you could be feeling the entirety of all the sensors on your network, right? All the log files, and as it goes, and then all of a sudden you could just like know that there's a server going down, or know that there's possibly someone breaching data over there, because basically the way we usually input data, right, through sight and sound is good for some things, but it has a fairly narrow bandwidth. And when you look at these alternative senses, you can actually really increase the bandwidth of things. So that can be really interesting. That's a like data visualization 4.0.
Yeah, and funnily enough, I mean, that session on data visualization actually does tie in with Internet of Things, because 9 times out of 10, the one thing you want to do is, what is my thing doing? And quite often there's sensors and measuring stuff or gathering information, like your rain sensors. And Scott Hanselman does, he has a blood sugar monitor, because he's a type 1 diabetic. Which is relevant to me, because actually my niece is also diabetic, and she's pregnant at the moment. And it's a real trial. If you're a type 1 diabetic and you are trying to manage your sugar, and you happen to be female and pregnant, it's life-threatening for everybody concerned. So those little devices linking off and sending a visualization, her mother and her father, who's an ER surgeon, can actually see that information come through. It's a really good use of connecting stuff to the internet and then visualizing it in a way that makes sense. Because she has I mean, she won't mind me talking about this because she's public about it, but she's a nurse. But she has an insulin pump, and it has an SDK and it has an interface, and it connects by Bluetooth to her phone, and then the phone actually transmits information up to some broker somewhere, an MQTT broker, I'm sure, or something like that, and gives readouts of her blood sugar and the insulin levels and stuff like that. And, the biggest time that's a risk for type 1 diabetics is when they go to sleep, because as you sleep, especially after you've eaten late at night, and she's a nurse and she works crazy shifts, like 13-hour shifts, and your blood sugar can drop to very dangerous levels, and you are not always conscious and capable enough to actually understand that the beeping that's coming off of your device is warning you you're in trouble. But of course, you know, with the dashboards and things like that her father and her mother have got, they can go, oh my word, quick, send someone round to literally save her life. You know, so it's not all about, it's not, IoT is not all Internet of Toys, which someone else said once. It is things, and some of those things are very useful and life-changing.
They are. Well, you know, another topic I'm really interested in is the right to repair, which is this idea that if you have a device, you should be able to decide if you want to modify it or how you want it to get repaired, right? Who repairs it and such. The counter argument is the idea that only authorized service centers should be able to do it, or only the manufacturer can control things and stuff like that. So there's actually a lot of laws going around debating this and such. But one of the places that comes down at is in medical equipment. And there is the argument that they make around that, the manufacturers, right, is that if you modify this medical equipment, you could cause it to function improperly, and that could be life-threatening. But Scott Hanselman, as you mentioned, his device is running custom firmware so that he can have more information and more control over it. I use a CPAP machine, so I found out I don't breathe at night, like really bad, and I found out that there's a guy that made, I think it's called Sleepyhead, that is a software that can read the CPAP machine logs and provide a lot more information. And there's a number of people out there that use that in order to have better control and better understanding about how they're breathing at night, so that they can have better control of that and take care of it themselves, because they can dedicate more time to it, even though they don't have the expertise of their doctor, but they can dedicate more time to reviewing the data and adjusting their treatment.
Well,
So,
I think as soon as you open these things up to, open source or public APIs and SDKs, what you're doing is going beyond the capabilities of the manufacturer, and that's a good thing, because it's one of the arguments for open source and open hardware is that if you're a company and you have, I don't know, if you're a big-ish company, you've got 1,000 people that work in R&D. Great, you've got 1,000 people who are capable of designing the hardware and bringing it to the market, but you've also got, of those people, 250 of them are project managers who are going to be having budgets imposed on them by salespeople who have their own goals for the company, and they make decisions in meetings where they say, this is what we want our device to do, here are the regulations that we have to follow as a large company. Once you open the hardware and the SDK up to a certain degree, it means then that you are able to give control to the user so that the user can then say, well, you've got your targets and your goals to ensure that your product is marketable and profitable in your arena against your competitors, but I can add my wants and desires and goals on top of that platform using the open source, and if I'm capable, obviously, using the open source and using the open hardware to take it into directions that either don't follow along your business pattern, your business model or business plan, and more into the realms of what is useful for me rather than what isn't profitable for you. And it's a good argument. And the Internet of Things is one of those areas, I think, where this is actually quite a lot more common because there's a lot of makers out there. I mean, correct me if I'm wrong, but I think that the Internet of Things is largely at the end of a keyboard somewhere. There's some person who likes to fiddle with hardware and hack software together rather than just regular Joe Public. I think that's typical. We've all got Alexa and stuff like that, but the Internet of Things is much bigger than that, and it's not just traffic lights and junction cameras and speed cameras and stuff like that. It's huge. I have one of these sous vide things that works IoT. It goes on an app, and a sous vide is such a disappointing technology. It makes great steaks, but everything else takes 3 years to cook. But at least you have an app that shows you how long it's going to take. Yeah, great. It's interesting.
So on the 23rd, the real-time streaming and message queues, that is it's a specific type of way of sending data over the internet, I guess. There's it's like WebSockets. There's I can't think of the names of the different protocols.
Stomp.
Yes.
Sockets, Stomp, MQTT. There's quite a lot of them. If they go on the Embarcadero blog and click on MQTT, a whole bunch of links will come up. And real-time streaming is another tag that's on there as well. If they click on the real-time streaming, a whole load of stuff will appear. And
actually, we have some brief presentation on that if you want to delve into it later once we have the simple slides there. Because I think we're drilling deep into the topics that we want to address later. But yeah, that's just one of many protocols for IoT.
So,
yeah. Okay. So yes, the Apple M1 is the new Apple ARM silicon that they're introducing. They're on the roadmap. 10.5 is scheduled to have what's it called? Support for the compiling for the Apple M1. So this is going to put an ARM processor on the desktop. The ARM processor is also what powers the Raspberry Pi and a lot of other single board computers. But in my opinion, this is going to be really big. If you look at a lot of things that's going on right now, Windows has had ARM support for a while. Just at the last Build conference, they announced that they're working with Qualcomm to build new developer boxes so people can start developing affordable developer boxes. They haven't announced them yet, but the guess is they're going to be about $100 Qualcomm Snapdragon powered box just for developing on. And then you look at the fact that, was it NVIDIA that just bought ARM? Yeah, NVIDIA just bought ARM, and both Microsoft and somebody else, Google and Amazon, have all announced that they're working on their own ARM-based CPUs as well. And also, ARM is more power efficient, and people are becoming more and more concerned about power efficiency and stuff. So it is going to be there's a lot of interesting stuff going on around ARM. So that will be an interesting one. We'll talk some about the Apple M1 processor specifically, but then ARM in general. Apple's announced that they are halfway through their plan to move entirely to ARM-based processors, no more Intel processors on Apple platforms. So the June 30th, I think that's going to be one you're going to want to check out for sure. On the 7th,
Windows 11 is being announced tomorrow, isn't it, Jim? Supposedly.
Well, it's, I don't know.
I'm fascinated to know what that might mean, whether it's an interface thing or whether it means that there's something cute happening in the pipeline. I mean, Microsoft are not very good at keeping secrets, but the big talk is that there will be a new version of Windows, and this might be Windows 11. But whether that will mean it will be targeting ARM, or is it their hybrid operating system that had with those little Surface fold-up devices? I forget what they called it now. Some kind of weird name that they abandoned. So.
Yeah, that's going to be interesting because they said that Windows 10 was the last version, but so I'm not sure if it's going to be Windows. I mean, it could be Windows 10 build whatever, right? That is a huge step forward, or they could be going to 11. I mean, Apple was on Mac OS 10 for the longest time, and they said, "Oh, now we're doing 11," and now again they're doing 12. So Mac OS 12.
Quite Spinal Tap, isn't it? This one goes up to 11. See, one more than 10.
Yep. Yep. So, and then the 7th is Docker containers and platforms as a service. That's actually really interesting. We did a webinar with Malcolm Groves a while back on that. It's kind of, the idea is the ability to, and this is actually becoming a lot bigger recently as well with Terraform and some other technologies. And it basically it's the idea that you can have more platforms, more instances of your platform or your deployment, spin them up quickly for the purposes of just reliability or the scalability and stuff like that, and testing. And so that's a great thing from a developer point of view, is that you can have your platforms you're testing on back in that testable state very quickly and spin them up. And so instead of having to have, all the different various databases or whatever installed on your operating system and worrying about all this stuff running in the background slowing your computer down, you can just spin up those instances of the database as you need them to develop against them. And then the last one we had scheduled is on the 14th, and that is blockchain and NFT. NFT is non-fungible tokens. That's really big in the news. So we'll talk, blockchain is part of the fundamental technology behind Bitcoin, which I'm sure most people have heard of at this point. We're probably going to talk more about, so we're going to talk more about the ideas behind blockchain and uses beyond cryptocurrency, like smart contracts, I can't know what's called, fintech, and you can use blockchain in messaging and log management. And the non-fungible tokens are this new way of selling digital assets or licensing digital assets. It's interesting. I think it's really interesting stuff, and I think you'll find it interesting. But there's some big news around Ethereum. So Ethereum is probably the second largest cryptocurrency, but it's not focused on the currency side of it like Bitcoin is. Ethereum is more focused on the smart contracts. A lot of the NFTs are run on Ethereum, but previously the all cryptocurrencies, all blockchains ran what was called proof of work, which is this idea that the computers, all the computers on that make up the network, are doing this work to try and calculate the next block. And the problem with that is it uses a lot of energy, a lot of electricity. So Ethereum has announced that they're switching to proof of stake instead of proof of work, which means that the energy consumption for Ethereum network is going to drop dramatically, which is going to make it a lot more sustainable. So anyway, I think it's an interesting thing, a lot of interesting stuff going on there, well beyond just cryptocurrency. So that's kind of a summary for you, Nicholas, of some of the topics. More details on what we're going to cover in those sessions, but so hopefully that's helpful to you. I have a couple questions here, so I'm going to try something different here. Let's see if this works. I have we're going to display the questions on the screen and then answer them. So we got a couple questions came in. There we go. So you should be able to see the questions now. First question is, how about security on Bluetooth pumps? So this goes back to we're talking about the medical devices. Bluetooth low energy can be easily hacked. That the pump monitoring is good, but some manufacturers want to provide meds through it, and security is just not there at the point where I would even suggest it. Yeah, so that's and that's one of the arguments that the manufacturers are making, right? Is that they don't want people going in and modifying these because that could potentially circumvent their security and introduce threats that way. But
this is the argument, like the pacemaker argument. Someone was saying that the next area of criminality for these people that are going around at the moment and doing these crypto viruses, where they, encrypt everybody's drives, which have been very successful. But they're saying that the problem is that if you have a pacemaker, which is electrical, they put up a little device next to you like a harness, and they can program the pacemaker. Apparently, I don't have one. I've never seen one, so I don't know. But the worry is that, obviously, if you were able to, you could create some kind of amazing virus that if your pacemaker connected to the internet in some random way, you'd say, oh, no, we've got the best protection ever. We've got absolutely rock solid encryption, and we've got this two-factor authentication, all the rest of it. But as we all know, sooner or later, someone makes a mistake and it's broken somehow, some kind of slip up, and the thing happens. And so the argument is that if you make the devices open, then people could abuse that and say, if you don't pay me 100,000 by next Thursday, I'll kill your father. I'll just turn off his pacemaker. And you're like, well, I'll just put him in a lead-lined room so he can't receive a signal. Well, yeah, but it's still a threat, and they could just kill a few people as examples. Remote control murder, it's very bizarre. But the fact that that could happen is not the reason not to do it, if you see what I mean. Because look at the Tesla, a car that you can take your hands off the wheel, sit back and let it drive. If someone's able to inject some form of software into there that can spontaneously cause a problem because you've put a roadside sign next to it saying Eddie's Hamburgers, and you don't know it, but your Tesla, when it sees that road sign and its cameras, it triggers it to speed up to 110 miles an hour in crazy mode or whatever the Tesla Sports has got and smash into the back of someone. That is another possible vector. The more we have devices connected to the internet, the more there are going to be opportunities to hack, because there is no such thing as a secure computer. We all know that. We've all got antivirus and we've all got firewalls and all the rest of it. But at the end of the day, the only secure computer is the one that's in a block of concrete buried in the ground and doesn't work. True? And the Internet of Things is just a massive target for everybody. But that doesn't mean to say we shouldn't do it.
I'm muted. Exactly. And in a lot of ways, the changes we've gone through in the last year have been things we should have done a long time ago, and we're getting a lot of growing pains as a result of everybody being online more and being more connected and classes being available online and stuff like that. We should have done it before, but we're doing it now, and so we are having the growing pains as a result. So yeah, security is a really, really important topic there. And we did the session on cybersecurity a while ago, and I'm actually planning to do a follow-up session. I'm working with a couple people on that, and hopefully have that in the near future to discuss that more too. But
actually, I was responding to this question online. Is actually nowadays, unless you're doing something truly personal as a hobbyist for you and only at home, you should never embrace using plain text or plain open communication protocol. Nowadays, anything that is from medium serious to extremely serious, commercial or enterprise, you must have encryption. So don't ever do raw packetings, and unless again you are just doing it for yourself or experimenting or for your personal projects. So a real serious project that you are developing for a company, for commercial deployment, must have encryption. So that's like a rule of thumb. Nowadays you cannot deploy anything in the open air.
Yeah, I would say even if it's something personal and like has no value at all, you probably should be doing encryption anyway. And I know I have websites that I don't have encryption turned on yet because I haven't taken unfortunately the host I was using won't let me use other encryption keys. I have to buy them directly from them, which is really obnoxious. So they're essentially, it's like ransomware. So I'm trying to migrate off of them, but anyway. Yes. Encryption.
I like it.
So Jim, can we show those slides just to show the audience some of the terms that we've been discussing, yes, that some of them may not understand what we've been talking? It already mixed a lot of key terms here.
Let's do that, and then we will, we'll jump to some questions, more questions, because there are questions coming in. So keep questions coming. We're going to talk a little bit about some of the core topics here, and then we'll go to more questions.
Here, let me take on this one slide quickly. So the point is, what is IoT? And IoT means Internet of Things, as shown at the very bottom. But how did we get here? So IoT is really like artificial intelligence, the machine learning. Many people see, oh, this is a totally new topic. It's not. If you see machine learning, AI, half of it, or around 60 or 70% of it, came from statisticians' theory, meaning linear regression and categorization. All that already existed. What has happened is that technology has evolved to a point that now we have really advanced algorithms that didn't exist a couple of decades ago. And then these traditional algorithms are now being enhanced with the brand new ones. And then now we coined a new term to say artificial intelligence. But point being is that many of the algorithms in artificial intelligence have existed for years, if not decades. So the point with Internet of Things is we're talking about, let me just quickly explain. We already have embedded systems in our lives. An embedded system is like your microwave oven. That means internally, it has a simple, very tiny microprocessor that is a single function device. The designer, the electrical engineer, along with the mechanical engineer, designed that microprocessor with a very simplified program that makes sure of checking when you're pushing the buttons, the function buttons of your microwave oven, the timing when you selected the time you want it to cook, and then when you hit enter. So this microprocessor is checking for those buttons. Once you click go, then it will turn on the internal oven and heat and wait for the time to cook that you have selected, and then stop and make a beep. All these functions are done by an internal simple function microprocessor, which is usually coded in C or C++, or in the old days, it was even in assembler. There was no chance to use C or C++. It was raw assembler. But now they were evolving as the technology has evolved. These very tiny microprocessors, and let me just tell the audience, we are so used to our computers nowadays that we lose the sight of what is a microcontroller. Our computers have gigabytes worth of memory, have terabytes worth of hard drive space. We have megabytes and gigabytes worth of bandwidth speed in our internet. A microcontroller, in comparison, is so tiny that these old ones, like the ones used for a microwave oven, the memory would be, in the best case, 4K RAM. That's nothing. For a computer, that's nothing. But for a microwave oven, it's enough. The only thing it has to do is check which buttons you pressed and then do some timer function internally. That's it. So the point being is that these microprocessors cost maybe $50 or even less in the thousands made by the factory. So you want a cost-effective solution that will serve the function of your device. And you will strip it down to the bare minimum so that it's cost-effective. So this is what happens in embedded worlds. It means it's a microprocessor that is, as the word says, embedded internally in a device, in a consumer goods device mostly. Can be in a military device, can be in a medical device, can be in your watch, any of this. And this is what we call an embedded system. It's something that is designed for a single function inside a device, mostly a consumer electronics device, which is totally different from your computer. Your computer is general purpose, it's totally interactive, you drive it, you control it, so it's a Swiss Army of a tool that can do anything you want. But embedded systems are dedicated to a single function. Then, as the technology evolved, this could do multifunctions. So now you could have, like in your current coffee machines, your current coffee machines, well, not the current one, previous generation coffee machines could, besides making the coffee, simultaneously they could froth the milk. So this was possible because these microprocessors were more powerful. They could have two internal cores. So one is taking care of your coffee, the other one is taking care of the frothed milk. So you started to add more functions to the embedded systems. And then it came to a point where these embedded systems could talk to a network, could do connectivity to a network, and then start doing some additional functionality once they are connected. I recall the first TVs that had connectivity to the internet were introduced in the 90s, some of them by Sony. At that time, we didn't have this smart generation of TVs that we are so used to them. This one only connected to a main server at the Sony headquarters, so it could download some TV guides sort of menu on your screen. So this was the very first example of an embedded system that was able to connect to the network and then get some dynamic content of the net and show it on your screen. So this was the very first samples. So very basic, very preliminary, very basic compared to nowadays standards, but that happened. Before that, you didn't have devices connecting to the internet. And then, to make the long story short, we come to the smart TVs, which were I think the experience of most of us with Internet of Things is when your TVs started to be smart. And that means now they have these applets. Nowadays to us is you expecting your TV to have these applets built in, Netflix or any other built-in thing. And now your TV behaves like a computer, or almost like a computer. So these applets add a lot of functionality to your TV. And nowadays they are looking more and more like a real computer, but they are still a small PCB, a small electronic board with the microprocessors and the necessary elements to run it. But since running a smart TV is much more complex, it's more and more looking now to like a computer. So they have been evolving from being microprocessors to a point where they are approaching the complexity of a real computer. And only mentioned to the audience. So at the point that they started to do this complex interactivity with the internet, that's when someone coined the term Internet of Things. And if you can switch to another slide, Jim, the first recognized device to be the Internet of Things is this Coke machine that was developed in the Carnegie Mellon University. They retrofitted a normal mechanical Coke machine and they added a PC internally. This is 1982. The budget for this was $1 million. Nowadays, you can do that with a Raspberry Pi of $25. But at that time, it was a breakthrough. So they was trying to prove that it could be done. There was really nothing special. And compared to today's standards, this is nothing out of the world. But it was a real breakthrough. And now this is the real event. This is the first machine recognized as an IoT, truly IoT device. It connected to a remote server, so it could report the actual inventory, the stock of the beverages inside the machine. Today, all of them do it. This is like a standard function, but this was the very first one. And it was not developed by Coke. It was done by the university. They tweak it and tamper with that standard Coke machine to make it IoT. But this is just in comparison. At that time, one of the developers, Kaiser, one of the leaders, said, one guy told them when they introduced this into the university presentation, they said, "You are kidding me. So are you saying that in a few years my toaster oven will have internet connectivity?" And they were laughing. And today we have toaster ovens with internet connectivity.
Yeah, and I think that's been on the cards for as long as I can remember, because at the time that you're showing that 82, probably just a bit after that, I worked for Dictaphone. I used to be, the dictation machines and all the rest of it, and it was all Unix based, and there was the internet didn't exist as such. I mean, there was Janet, which was the Joint Academic Network for the UK, and there was CUNet and a few other systems cobbled together. But it was the Wild West of the internet, and we had devices that were connected across that, and we're talking using UUCP, if anybody remembers Unix, and Unix to Unix copy was the name of the system. And the devices that we had connected were they were used in call centers, and they recorded phone calls. So if you dialed 911 or 999 or whatever your emergency code is in your country, when you were speaking to the operator, the call is recorded. And back in those days, it was recorded actually on tape. And that device would actually store that information, but it was controlled from a central area, and that was connected to what wasn't the internet, but it was the internet. So I think, when we talk about Internet of Things, in some ways it preceded the Internet of Internet. The actual web pages, and even just the old bulletin boards that we used to have back in the day, which preceded web pages. The devices were one of the first things that we actually connected up to what became the internet, because we needed some way of networking together bizarre hardware. And the Coke machine's one of them. The web camera, if anybody remembers the original web camera that pointed at the coffee pot, the very first and it's not there anymore, unfortunately. They took it down, which I think is a travesty. They left it up, but it was a webcam that pointed towards the coffee pot, so that someone upstairs could check whether the coffee pot was empty or not, and if it was empty, then they would come downstairs. So there was a use for an internet device, but obviously it didn't do anything. Now, some of the hardware we sell are things like hand scanners. Okay, and they're connected across the internet, so that people put their hand in, it biometrically recognizes their hand and clocks people in or out, or opens a turnstile door, so that builders or security people can go in through the turnstile. They're used in a lot of airports and stuff like that. And at one demonstration, the guy put the hand on, and it opened the door, and he said, the customer said, "Yeah, it's great, it's great. When it can boil the tea for me, I'll buy it." So whilst they were out having lunch, our engineer was there soldering the relay together into a kettle, a British kettle, so that it could be powered on. When the guy came back in, he puts his hand on the hand scanner, it verifies who he is, turns on the relay that would normally open the door, turns on the teapot, boils the tea, and we got the order. So, that was probably 98 to 99. Internet of Things has been around for a very long time, and like I say, preceded a lot of the kind of technology that we take for granted now, like web. We all tend to think of the internet as being the web, but actually it was much more than that, long before, primarily email and chat. Everybody's stunned into silence now.
No, actually, it was. I was just the other day I was reading about Amazon is selling a microwave oven, IoT microwave oven that is. I think they're effectively selling it below cost, but it has the ability to subscribe to microwave popcorn, so that it knows how often you're cooking microwave popcorn and will keep ordering more, so you always have microwave popcorn on hand. So, and the same thing with the smart TVs that Miguel talked about, is a lot of those smart TVs are sold at cost or below cost, because they are using the data they can collect through the platform, the OS platform that's on there to collect
the Nielsen viewing statistics.
Yeah, the advertising.
Nielsen.
So
yeah,
it's interesting and so that's one thing that's showing up a lot is the functionality may not be so much for us as it is for companies' ability to sell to us.
Yeah, my wife's company, they're a big the Nebraska Furniture Mart. So if you know what Nebraska Furniture Mart is, she works for those in their computing department. But they have a lot of home goods and things like that. That's what they do, and they have these top-end kitchen areas where there's very expensive kitchen ranges that I look at and think, oh, I wish I could sell a kidney and then afford one. And they have fridges there that have got what appear to be glass fronts. So you look at the fridge and there's all your stuff in there, but actually it's a screen. And what happens is when you put your goods into the fridge, it scans the label as you put it in, if it's got a label, or you can select from a menu and say cooked chicken, whatever. And it can suggest menus based on what you've got in your fridge, which is weird. And also reorder things. So if it knows you're running that short on milk, it can actually go off and say, oh, you've only got like half a gallon of milk left or something like that. Based on your current usage, you should reorder. I mean, it's a bit weird. Your fridge starts telling you what you should and shouldn't buy and when you should buy it. Skynet is here and it wants to know what you'd like to eat. And Amazon.
Jim, can you show the next slide?
Yeah, so I was going to say Miguel's got some more stuff here about some of the technologies. This is good stuff here.
Yeah, because one of the key things when you're talking about IoT is that you're not talking about your normal everyday computer. You're talking, as we explained previously, of either single function devices or more recently, very small computers that are designed or purposely made for a single function, but we're going backwards. On one hand, we have these microprocessors that have evolved and they are matching the full-blown computers. But in the other hand, the computers have been reducing in size more and more, like at the Raspberry Pi, that you have a full computer on the size of no more than 10 square inches. So at that cost, it makes sense to now make a single function device with a full-blown computer. But because the cost has been driven so low, and now from the two sides of the spectrum, they are merging into the middle point. You can have IoT devices by going with the traditional method of having microcontrollers, which is as you described, Jim, Arduino is the most common microcontrollers development platform nowadays. What Arduino did, for those that don't know, what they did is, before they came to existence, developing for microcontrollers, you had to rely on vendor. You had to rely either on Texas Instruments or NXP or STMicro, and then you had to purchase a development kit. They would give you a huge board where you can plug in the microcontroller, and this board would connect to your computer. You have an IDE, just like the Delphi and C++ IDE, and that IDE is dedicated to that board only. Then you have all your development environment for coding for the microprocessor, and then every time you program to the microcontroller, the board will do all the conversion and the transcoding on the binary and program your microcontroller. And the board itself will give you some general purpose inputs and outputs, and every functionality provided by the microcontroller will be available in some connectors on that board. That was the traditional way to do it. And to purchase these development kits, you're talking about $10,000 or more each one. Arduino was a project in Italy by some electrical engineering professors to come up with something similar to these development kits, but totally open source. And fast forward to today, Arduino is now the de facto standard for programming microcontrollers. And Arduino originally were supporting the family of Atmel controllers, but they are so popular that now support almost every family in the world of microcontrollers for almost every vendor that is relevant in the market. What the advantage of this is, instead of being single locked with a specific vendor and with their specific tools, Arduino is open source both in the hardware and the software. The two things are open source. So you can create your own, if you want to, you can create your own Arduino development boards if you are an enthusiast in making your own PCBs. But if not, you just purchase one commercially of many vendors that provide them. And also you choose your own microcontroller. And the good point is that you have a single unified development environment. The IDE and the editor and the compiler provided by Arduino is standard. So you have the same user experience no matter which controller you chose to develop with. That's on the Arduino side. So some of our traditional Delphi developers may have not had that experience yet. They have been always in the full-blown computer world, developing with Delphi or C++. But this is what happens in the low-end side. Low-end side, not meaning they're not powerful. In low-end side is dedicated microcontrollers that are not a full-blown computer. And the Raspberry Pi is the one that comes from their end. It's a miniature full-blown computer with a full operating system made in a very small size and at a very low cost. One of the targets from the British developers of the Pi is that they wanted to come to a price point that it was so cheap that the students would not feel bad by destroying them when they are debugging or trying experiments in the classroom. So that was a key point, because before them, there were similar computers like the Beagle board from Texas Instruments, but this cost 10 times more at that time. Nowadays, the Beagle board had to reduce this price a lot, and now they are priced similarly as the Pi. And a new breed of copy clones from a lot of manufacturers have come outside that clone or are similar to the Pi, and you call them Banana Pi, or Panda Pi, many things that are similar to the Raspberry Pi, and in theory, they provide the same development tools. And they try as much as possible to be as close to the original hardware of the Pi, so you don't need to, if possible, you don't need to change or modify your code so they can run in these alternate vendor computers. Okay, so the point being is that you can be either on the side of a full-blown computer, miniature size, like a Raspberry Pi, or you can be on the side of a dedicated microcontroller. But every day, as technology evolves, this gray area between of them is get narrower and narrower and narrower. So when you are in a truly microcontroller world, that's what I'm presenting this. In the microcontroller world, you're talking about devices that are resource constrained. Again, the available RAM is tiny compared to a full-blown computer. The cores, most of them have single core. If you're lucky, you have a powerful one with 2 cores. The speed, most of these microcontrollers are still running at megahertz, not gigahertz, but megahertz. And some of them intentionally, you can slow them down to kilohertz for power saving issues. So both the speed at which they run and the resources they are capable of utilizing for running your code are totally different from your full-blown computer. So when you're developing for these embedded systems, you must have always, like you did in the 80s with Pascal, when we had computers, the XT computers and the original PCs, that were really resource constrained. Microcontrollers are still resource constrained, mostly. So you have to keep that in mind every time you're developing for an embedded system. Now, just wanted to show on this slide that when you are on that world, these are the communications protocols that you use for communicating with IoT. Why I mentioned this? If you are with a computer, you will mostly use a REST endpoint, a REST service, period. Why? Is the industry standard nowadays. If you are really in the corporate area, you may use a SOAP, but let's say REST, which is HTTP with RESTful services. And that's the de facto standard, and REST-Studio provides very nice tools for developing with REST services, like the REST debugger and the REST client and all the tools available. When you're in a microcontroller, REST is a luxury. Why? Because on the microcontroller level, all the overhead of handling the headers of the HTTP transmission and waiting for the confirmation and going back and forth is really heavy compared to the capability of the microcontroller. So you want to use a much lightweight kind of protocols when you're at the microcontroller level. The most popular, and I would say the de facto standard when you're with IoT, is MQTT, which stands for Message Queuing Telemetry Transport. That was developed by IBM purposely for IoT applications in the late 90s. So compared to HTTP, I'll just give you some numbers. the same piece of information that you can send in HTTP REST services compared to MQTT is 10 times lower in size. MQTT is very streamlined. It has a lot of the packet is binary coded. So the total bandwidth that you need when you're transmitting messages and packets with MQTT is much lower and reduced compared to HTTP. Another protocol that is very popular is the Constrained Application Protocol. Just one thing to mention, MQTT is actually a messaging protocol, which means there must be a main broker, a server, that is holding the messages for you. So you subscribe to that broker, to that server, and then you subscribe as a client, and then you either publish a message or retrieve messages from the queue. So MQTT relies on that middle component, a broker or server. Constrained Application Protocol is actually HTTP, but instead of making all the wrapping and the enveloping of the HTTP packet, instead of doing it with text, if you have ever seen how the HTTP packets are made, it's pure text. The HTTP protocol has always been plain text. But if you see the whole package, you see that a lot of that text is occupying a lot of space. So Constrained Application Protocol is the same implementation in theory, but using binary codeds instead of the full text. That reduces the size of the packet considerably, but it's modeled on a one-to-one structure-wise and framework-wise to HTTP. So there are some specific applications that once they receive the packet from an IoT device, since CoAP is intentionally made to model HTTP, these applications can convert it to full text and then retransmit it to a real server, and then they will receive it as HTTP. That's the whole idea, that when you want to rebroadcast or retransmit, then this is a good option. The devices themselves will use CoAP internally, which is lightweight and fast. But if you want to retransmit it or do some sequencing, you can then convert it to real HTTP. It's a very straightforward conversion and mapping. There's another data distribution service. It's an evolution of MQTT. This is more oriented for heavy industrial servers. And then last but not least, we do have REST services in IoT, especially because the newer generation of microcontrollers now can handle it with good efficiency, which maybe was not the point 10 years ago, but nowadays you see a lot of the microcontrollers with enough power to handle the real full-blown REST services with no problem. Should we go ahead with the next one, Jim? Next slide, please. Yeah, okay. And last, just to give you a good grasp, that was on the protocols used. So on a computer, you use mostly REST. I introduce you to those protocols that you would use in an IoT device. And these are the networking protocols that you would use. Again, in a computer, you will use either Wi-Fi or a wire LAN, and that's it. But in an IoT device, you have all these additional options. You still have Wi-Fi, and many IoT devices for consumer use Wi-Fi, your local Wi-Fi at home. You also have Bluetooth. You have the classic Bluetooth, which is from versions 1 to 3. And then you have the new Bluetooth, which is the low energy. The key difference with this new Bluetooth is it has some power saving options. So it's faster and uses less power compared to the classic version. Strictly speaking, it's versions 4 and 5, but as a gimmick for marketing, they call it Bluetooth Low Energy, BLE. Zigbee is a competitor of Bluetooth. You see this in many microcontrollers by some vendors because they provide some built-in libraries for it. The advantage of Zigbee is that the radio signaling, the transmission power is higher than Bluetooth, so you have a longer range. You have like almost 100 meters. Compared to Bluetooth, there is no more than 10 meters. So Zigbee has been very popular. It's not, I would say, a de facto standard because you are locked into those vendors that provide Zigbee, and this is implemented electronically in the board of the IT product that you're purchasing. One technology that is being very popular recently is LoRaWAN, which stands for Long Range Wide Area Network. Think of this like a cellular radio transmitter, but instead of using the already existing 3G cellular antennas, you deploy your own. So you deploy your own repeater, which they sell very cheaply out in the market because it's an open source technology. It's patented by the French company that developed them, but you are free to use them and implement your own repeater. So LoRaWAN has been very popular, especially for IoT in the industry, in industrial environments, because you don't need to pay licenses or fees, and you don't need to hire cellular carriers. So it makes a lot of sense if you have a factory that you need to deploy 100 IoT devices to monitor your industrial production. It makes sense to deploy your own repeaters in your company layout. You implement them yourself with your IT department, and then you have immediate communication with all your devices. LoRaWAN has been expanded a lot lately. And last but not least, we have cellular technology, the 4G technology, officially called long-term evolution, or LTE. The problem with cellular, this is something that many of our audience will not be aware of. The cellular phones that you carry in your pocket are very power hungry. Even there's been tremendous advances in electronics to reduce the power they use, you still need to charge them every day. When you go to sleep, you have to put them to charge. So in an IoT device, in many applications, this is unthinkable. You cannot be recharging that IoT device every day and have some technician or someone to go recharge it. So this has been a big problem for deployment of the cellular technology for IoT devices, until 3-4 years ago that there was a new revision on the standard. They acknowledged that it was a problem for using, because the advantage of using cellular is that it's ubiquitous. Ubiquitous means there's already a huge infrastructure around the world with cellular antennas. So you do want to take advantage of that. But the problem is they were not ready for IoT in terms of low power usage. So the newer standards that have been deployed these last 2-3 years are called LTE, again, which is, take it as a 4G cellular, category M1 and 2, which is our medium bandwidth. And then the real killer as an application, as a new protocol, is Cat MB1, better known as NB-IoT. That stands for narrowband IoT. The difference here is that your phones, when they connect to a cellular antenna, they use up to 32 multiple channels simultaneously to increase the speed of transmission. That means that is using a lot of power in your internal transmitter in order to achieve that huge transmission. That's what you want in your phone. And you don't care because at night you will recharge it. But in an IoT device, you want something that if requires recharging, it might need some recharging maybe every month or even longer. So you don't care much about these huge speeds. You need it in your phone because you are consuming media. You're downloading web pages, you're downloading video. But in an IoT device, you only want it to collect data and transmit it to your server. That's it. So you don't worry much about the huge bandwidth. You just want it to be very, very low power. So NB-IoT uses what they call sub-bands, meaning it's a fraction of the actual frequencies used by the full-blown cellular signal used by your phone. And this is what they had to actually invent, like a subset of the current technology that your phone is using that is capable of handling the very low bandwidth needed by these IoT devices. And then that means that these microcontrollers will need a very simple transmitter with very low power. And then this can last months, if not years, without having to have a recharge. These are having the real killer technologies for IoT devices in the last 2 to 3 years. Just to show to the audience, I have here one of these. This microcontroller is a very modern one, has been in the market for no more than 2-3 years. It's actually, let me remove so they can see it. This is from a British company. Actually, all these new things, the Pi Arduino came from Italy, the Pi came from the UK, and this one also comes from the UK. This is a microcontroller. Actually, it's a system on a chip. You can see that it's actually a small board, and this small board has internally a microcontroller, an ESP32 from Espressif, and on the other side has a cellular modem NB-IoT, which is made by a French company, Sequence. So all of these integrated in one single board. Here you can see the SIM card on this side. So on the bottom is the SIM card. And
we actually use these devices for some of our time clocks. We have a device that's got a little Ethernet connector on the bottom, and then it connects off and does IoT stuff across one of those devices. I'm not sure if it's the same manufacturer. I don't really want to give away any information that I shouldn't. Yep, no, it's not the same one. That's good. Okay, I do, because sometimes I get told not to say stuff about certain hardware that's being used by people I write software for. They get all worried about intellectual property, but but they connect it in, and exactly what you were saying was bang on about the narrowband IoT, because time clocks only send very small amounts of data on a regular basis, and the biggest problem they have is they don't want to have a wireless access point, because unless you properly secure it, loads of people walk along with their cell phones and they connect to the wireless access point, and these things have a limited data card inside them, and it runs up a huge bill. And that's happened. There's some grocery stores in the UK that had their time clocks in their similar devices connected up with these wireless routers. Somebody misconfigured them, and it became public access points. So all the customers walking around connecting to the internet on their cell phone didn't realise that they're actually going across this system that was charging a fortune to the grocery store for the bandwidth. Got to get it right, kids. When you connect things to the internet, make sure you do it properly, otherwise you start to get a lot of trouble.
There was a comment. Oh,
yeah, go ahead, Jim. Go ahead, Jim.
Oh, I was going to say there was a comment about tightening the loop of design to deployment and stuff like that. And it's interesting because you look back to like the original game consoles, the old Atari and Nintendo, there was no mechanism for update, right? So the games took longer to develop, but because once they shipped, they were done. But then today, it's really common for all software or games, especially big complex things, to have updates that ship on, on the release date. So the advantage of having the faster, tighter loops is that you have more updates more frequently and stuff. But I was also going to comment about the 4G LTE cellular. So the CPAP I have has a cellular modem in it, and it's connected, but it's not internet connected, in that it connects directly with the cellular modem to the central server to get updates and send the monitoring data and stuff like that. So, and I'm guessing that the doctor then goes over the web to access that service to get the data from there. So it's weird that the device itself, the internet, but it goes through a server to get to the internet.
The service providers that provide the SIM cards, most of them have a special service that is exactly for that purpose, for those devices. I don't know about the CPAP, but certainly for things like the time clocks and the hand scanners and the door opening biometric things, we have a number of deals with the telecoms companies, and they provide a data card that is a SIM card, but although it's got a phone number because of some anomaly to do with the internet back in the day, some kind of, I don't know, hangover, but the phone number itself doesn't do anything. It's completely non-functional as far as I'm aware. It can't make or receive phone calls, and if you try to phone the number, it comes up with a number unobtainable signal, because we've tried it. But what it does is it provides this data connection, and that's all it can do. It can just do data and nothing else. And weirdly enough, we have a little device that's about that big, that our engineers go around and because customers go, I've got 5 bars on my phone, why can't my internet device work? Well, because your phone has got a massive, great big, as Miguel was saying, it's got a huge, great big battery that is powering this thing and pushing the power out, and that's why when you hold your phone up, you'll get 3 or 4 bars or something like that. That is not how you test whether the Internet of Things data card works. We have a special device, and it'll tell us which service providers are providing a data signal and the quality of the data signal. So it's not, if you speak on your phone, sometimes it depends on the service provider. If it's something like Sprint in the US, their system is CDMA, and therefore the voice traffic is carried as voice traffic. But Verizon is voice over IP. So when you're talking, you've got an internet connection between your phone you know, the other person at the other end, and the traffic is carried, it's encrypted and put into packets, and so it's very, very clear. They call it HD voice and various things like that. Well, with the Internet of Things data card, it's exactly the same thing. The quality of service is as important as the strength of the signal. The fact that you can get what look like 5 bars is absolutely no good if that channel traffic is completely you know, competing on the access point that you've got, you know, out in the field or wherever this, you know, your phone provider has got that device. So the little device that we have tells us how strong the signal is, you know, how many watts or milliwatts or however they measure it, what the quality of that signal is, and which of those service providers is the best one to choose, because we will have a deal that will say, well, you can use Verizon, you can use Sprint or whatever, and that will give you the best signal. And that's in the UK, so it's not really those service providers, but it's generally how it works. There's been a few questions as well. We should probably address some of those. One thing that people have been asking about, by the way, and this is probably important, definition. People have been asking about MQTT and saying, where can they get components for MQTT, etc., etc. They need to understand what MQTT is. Someone said, well, UDP this, and there's a difference, okay? MQTT is an agreed set of standards for communicating, you know, and an agreed protocol for that communication. Somewhere, as Miguel said earlier on, there is a thing called a broker, and the broker is like the telephone exchange in some sense, that your devices that are using MQTT or your app, your Delphi app or your mobile phone app or whatever, probably the same thing, they subscribe to the broker, and there's a whole little protocol of exchange messages that goes on. I think it's MQTT has got this end of life message as well, that when your connection drops or your device is going away and disconnecting, it's called last will and testament, I think. It sends this last will and testament message to say whatever you wanted it to say. So you might say, broadcast some message that says, Ian's time and attendance monitor is disconnecting now, and then everything that's subscribed to my channel, because MQTT supports the idea of channels and messages on those channels, everything that's connected to those messages on that channel will get my last will and testament message when my app closes. MQTT broker is the bit that makes all of that magic happen. It is not the transport protocol. So the transport protocol, MQTT, could be operating over WebSockets. It can operate over, you know, raw sockets and things like that.
Hold on right there. Hold on right there. It is a protocol. In the terms that it only needs a low-level protocol like TCP. It requires TCP, but it's a protocol in its own. In other ways, it's at the same level of HTTP. It's
yes,
not
that's exactly it.
You know.
As I said, WebSockets. WebSockets are a good example. WebSockets are a way of transferring data backwards and forwards, and HTTP will sit on the top of the mechanism for making that connection. And the same with MQTT. HTTP, which we know as web pages, is literally on the same plane as MQTT. You agree?
Maybe you can showcase something to the users so they know what we're talking about.
Yeah.
Let me show them this. I have this simple device here.
Diagram.
I have this simple device. This simple device using that microcontroller that I showed to you. This one is live. This is a simplified version. I only added a temperature sensor here. It's an NTC temperature sensor, and it has also a voltage level. So it's measuring the voltage of its own power supply. So very, very simple basic system. What you can see is that the device itself, the only external components I had to add in this is not the only one, by the way. There's plenty of vendors now offering similar solutions. I'm just offering this one because to me it was very impressive that in one single chip, it includes the NB-IoT, which is to me, I think, the the most efficient one in terms that is utilizing current infrastructure. You don't need to deploy anything. You'll use the current cellular antennas that are all over the world. You just need to make sure that your country supports it. This is the problem. NB-IoT requires you, as I showed to you, requires special SIM cards. It doesn't use your standard SIM card. So the SIM card that you need to install must come from a carrier in your country that provides this very specific technology. So don't confuse it. It leverages the current cellular infrastructure, but it's not your standard SIM card that is in your cellular phone. You must get these special SIM cards from a carrier in your country that offers the service. And then you need to be aware of the coverage, because some people will say, oh, I solve it. I can install it in the outdoors or in a park. But if there's no coverage by your carrier, then you're dead one. So once you get
my experience of those SIM cards, sorry, Miguel, my experience of those SIM cards as well is that if you speak to a regular person on the phone from your phone carrier, they're going to have absolutely no idea what you're talking about. We have a connection with the carrier who specializes in those kind of SIM cards. If you phone up your regular phone company and say, hello, I'd want one of these special cards, the person on the end of the phone almost never understands what on earth you're talking about. You know,
that if it's able to connect, and that holds true for Cat M1. Cat NB-IoT won't connect. It uses a total different coding on the frequency, so it won't connect. Cat M1 can. And actually, you can use Cat M1 as a low bandwidth alternative to your cellular. Why you would do it? Of course, it's stupid, but for playing around, you can do that. NB-IoT, it won't work at all. It just a sub-band frequency, which definitely will not support a normal communication. So point being, as we have this thing working with the sensors, and I will share with you how it looks. I'm running a very simple application that is just polling the data and creating the MQTT messages. All right, so you are looking at my screen right now. And this window here is the console of that device. It's connected through serial cable. So you see here, this is the looping. So the area where it is collecting the data is here. So it's collecting the values from the sensors. Then in this part, it is connecting via the cellular, the NB-IoT cellular connection. And then connecting to the server, to the broker, is assembling the MQTT package and sending the package with the sensor data that it just read. So this, actually, what you see there on the screen is the real packet. It's a JSON packet. It's a JSON coded data packet that is just embedded as the payload of the MQTT message. And then it gets sent to the server. And the server is here. I will put it in live receiving. You see these things is I have enabled the built-in MQTT client of the server. So the server is now listening live to what the device is sending. So I'll just wait for the next polling time so you can see that one. It could come in anytime. So I'll just show you while it connects in the next polling time. This is a sample of the data that it have been showing, that it has been collecting as we have this conference, this presentation. So you see the time the data was collected at the device. This is the time that it was received by the server. And here you see this data, the battery level, 5.19, and the temperature from the temperature sensor. So that's it. I made a very simple one for the sake of this presentation. So you can see how it looks like. And now let's go back to the real-time and wait for the polling here. I switch back to the console of the device. This is a simple text console. These microcontrollers usually don't have a graphical user interface, unlike a Pi. A Raspberry Pi, since it's a full-blown computer, they do have a graphical user interface. Microcontrollers, usually 99% of them just have a raw text console. And this is the one I'm showing you here, right here. And it's just showing the activity of the controller, how it is collecting the data, again, in these JSON packets. And they've been collected, and then once connecting, well, right now I have an issue here, but once it connects, you should see these packets right here. Let me reset the device to see if it connects. But in the meantime, I'm doing a reset. You will see a reboot and resetting the device. We're rebooting from scratch. One thing about these microcontrollers is you see part of this initialization, the internal clock is set off, is completely wiped out. So one of the things you have to do with a microcontroller that normally you don't care on your computer is you need to sync the real-time clock. So in this case, one of the main functions that the microcontroller does when it boots up, first is trying to attach to the cellular antenna. It's connected now. Another thing, you need to control all the steps of having connectivity manually. Again, something you don't need to do with your computer. But in a microcontroller, everything, you will have the full control. You have the full steering wheel of anything that a microcontroller is doing. So, okay, it's crashing because I'm doing some shortcuts right now. As I'm holding it in my hands and creating some shorts. So bear with me, please. But the point being is that in the microcontroller, you need to do everything, including starting the communication, making sure that the communication was established, making sure that the modem is successfully connected, and then when sending the actual packets, you also need to be taking care of that. That's a big difference compared to doing a computer program, especially compared to doing a Delphi program. That's one of the main reasons we all love Delphi. You don't need to care. You just use components that are already developed by someone that they just work. So you don't need to do this low-level maintenance and maintenance of the functionality of your device. So let me just wait until it's working. In the meantime, I switch back to Jim and the rest. Once it's working.
This is a great demo, Miguel. Great, good demo.
Okay, so you can continue speaking while I wait that this has a successful transmission. So I'll leave it in the background while we continue.
Let's answer a couple of questions, actually, Jim. Someone was saying, I've lost that question now. They were saying, oh, MQTT is an application protocol, not a communications protocol. I'm not quite sure what difference they're trying to make there, because I would say it is actually a communications protocol. It's an agreed set of standards by which applications can communicate. And the idea is that the scenario for MQTT is that there is a broker there which you connect to and subscribe to, and the general, and in fact there's lots of blog posts about this. So I've got some links that we'll put in a handout at some point on Embarcadero blogs, but the idea is that you connect to the broker and you then will connect to a channel. So you might have a channel called TCoffeeAndCode, perfect channel. Okay, your app connects to that channel, and so do other people's apps using MQTT. You can then publish messages to the TCoffeeAndCode channel on the MQTT broker. And when you say, are there any messages, the messages will come down to you from that channel. So everybody connected to that channel on the MQTT, the same MQTT broker, will receive those messages. Now, in our sense, it could be the questions and answers. For example, it could be that we all subscribe to the TCoffeeAndCode MQTT channel, and people post a question up, and we interpret that in our little question browser here as a question. So we might say, we'll agree that if we begin with the Q, then it's a question, and the text after it is the text of the question. And then in order for one of us panelists to answer, we would send a message up to the same channel, and it might begin with an A. And the A, we then say, is an answer to a question, and we might have to have some way of referring to which question we're answering. But MQTT at its lowest form is basically a packet of information or text, and can be other things as well, like, you know, images and stuff like that, as long as you know how to interpret that data. But it's a very, very simple way of everybody communicating together, and in that sense it's similar to things like Stomp. It's similar to things like WebSockets. You connect up and it's a send and receive protocol. So when you say it's an application protocol, I'm not quite sure what you're meaning by that, but what's the difference in that sense? Do you think there's a difference, guys, or? I mean, what would you call it? I would say it's communications protocol, but I mean, I know underlying it, there's some other low-level handshaking nonsense going backwards and forwards and packets with headers on, stuff like that. But actually, MQTT, yes, I suppose it is an application running on top of the communications protocol, but really it is a communications protocol. We agree how to subscribe to the channel and send information backwards and forwards.
Sometimes it's a matter of semantics, because everything is always layers and layers of abstraction, and so you know, semantically you may say it falls into one category or another, but there's always two different ways to use it as well. That reminds me, there's another question here about what's the most energy efficient or power efficient way to communicate with IoT devices. There's a lot of different options. The reality is it's going to depend on your use case implementation, because if your IoT device only needs to communicate rarely in very small amounts of data, you know, it could might find that having a cellular modem where it actually dials up occasionally is the most energy efficient for that use case. Whereas if your application needs to receive data all the time, then maybe something like Wi-Fi, where the light, and it can even be light that's not in the visible spectrum or so low that it's not visible to human eyes, can be sending data to your device, and that might be energy efficient, right? And so there's a lot of things that could go into determining what's most energy efficient, but there are a number, and that's the reason why there's a few different options to choose from, whether it be Z-Wave or Zigbee or Li-Fi or whatever, and of course then you have, it's like with MQTT, there's different layers, right? So you have maybe what's giving you the physical connection, right? Whether it be Z-Wave or Zigbee, but then you could have the protocol on top of that, right? How that's going, and then you have how you're communicating over it. So can't give you a definitive answer.
But this is the holy grail question of everybody going into IoT arena, Jim, because the answer is a complex one. My take on this is that all these options that you have for connecting, the ones that I showed to you, even Wi-Fi, are a good option, provided that you have a good control of when it is transmitting. The single most consuming power-hungry device in an IoT device is the radio transmitter. Call it whatever it be. Wi-Fi is a radio transmitter. Zigbee is a radio transmitter. Bluetooth is a radio transmitter. LTE NB-IoT is a radio transmitter. All of them are transmitting radio signals. This is the single one that consumes the most power. So what you want to do is, as you said, you need to develop your applications and your logic in such a way that, depending on your application, you try to transmit as continuous as possible, but not like in your computer. Your computer can transmit every half second with no problem. But in case of an IoT device, you can do that only if you are continuously powered, like you have a power socket driving it with a power supply. But if you're on batteries, you can't. Then you must have come to a compromise position. How often you want this to update the data to your server, and at the same time, how much battery you want to save so it can last longer. Having said that, the one that was really out of the equation a few years ago was cellular, until they came up with the NB-IoT new technology. That's the main reason that drove the cellular 3G, 4G group to create this technology. They were being pushed out of the equation for IoT devices because they were really power hungry compared to the other options. Nowadays, today, any of them is good enough, but goes together with a good design of the electronics. In other words, if you're tying it with a microcontroller, such as the one that I showed the audience, you make sure that your microcontroller is also low power. And that microcontroller, when it's not doing anything, can also go to a sleep mode that will consume almost nothing of power. So it's a combination. Nowadays, it's a combination of the logic, the electronics of your microcontroller, and the radio transmission technology that you choose. but all of them go hand in hand together. It's not one single selection that solves the whole thing. All of them are so intrinsically related that any of them that you go wrong, then the whole thing will not work. In other words, your batteries won't last. I have seen IoT solutions that last almost 3 years with no need of changing a battery. These ones is like for electric power readers. They are collecting the power reading and they are updating on either on a daily or a weekly basis. So they are reducing the transmission to the bare minimum, but they are working, and then they reduce the maintenance of these. They reduce the visits that a technician needs to do to a site in order to replace the batteries, and they accomplish it very nicely. And this is a single function device. It's continuously reading the power, and then once in a while will connect and send the data. Other solutions will require you to update it more often, like the one I'm showing here right now on the screen. This is connecting every 2 minutes. I did that intentionally so you could see the data quickly on the server. By the way, now it's been sending, and you can see these are the raw messages in JSON being received by the server. So this is one, this is another one. And here you can see the data that was read. In this case, this application will keep the data in a local storage. So when it finally succeeds to connect, it will send all the accumulated series of data. You can see some timestamps there. This T1 is timestamps in Unix Universal Time format. So this is the way to go with IoT, since you cannot rely that it will connect always. You must have some strategy to keep the data stored until you can successfully connect and then send everything that has been accumulated over time to your server. So, but yeah, that's the holy grail of IoT design systems, is all components are key and all of them contribute to the overall power efficiency and power energy consumption.
Great stuff. I really like this demonstration. This is an excellent demonstration of what's going on. And the JSON there just kind of proves the point that we were talking about, which is saying that, you know, what is being sent backwards and forwards is under your control. It could be anything.
Exactly.
You know, the encoding and decoding is up to you, and that takes a little bit getting used to, I think, with some of the protocols. Someone mentioned Don O'Brien was saying that Zigbee was used by the Mars Ingenuity helicopter, and he links to a
exactly.
ZDNet. I mean, that Ingenuity helicopter, what's going on with that? Those someone was saying the other day, Mars is the only planet that we are aware of that's completely populated by robots. and it's absolutely true. And I thought about it. I thought, actually, it really is. But the Mars Ingenuity mission and Mars Perseverance, which is linked to that, is absolutely incredible. But also, the weird thing is, when you read these articles, you realize a lot of the technology that's running under it is stuff that, you know, all of us that are watching this webinar and participate in this webinar could be doing. Not to the extent they are. I mean, they're rocket scientists, literally the cleverest people on the planet, but and off the planet, some of them. But yeah, it's using Zigbee in the background to talk to something on another world. That's pretty impressive. I would be very pleased if some of my code made it up there.
Yeah, and just my take on that, as I mentioned, the advantage of Zigbee over Bluetooth, they are very similar, actually, even in the frequencies they use, but Zigbee has a longer range. So if you already have Bluetooth implemented and suddenly you need a longer range, it's like a no-brainer solution. Jump to Zigbee, you need to do very minimum changes on your code. The designers, original designers of Zigbee, that's what they had in mind. It's like it's a superset of Bluetooth. It's not the same names, they cannot do it because of the copyrights, but overall the implementation of how you do Bluetooth, to just change the name is calling the Zigbee libraries, but it's almost the same. So it's only names that you can change, and suddenly you have a longer range.
Yeah, it's very cool. Yeah.
So I would call Zigbee like a super Bluetooth or extended Bluetooth.
The thing that I like about this is that I'm old enough now that Jim and I were discussing my relative age earlier on, but I'm old enough now to have all the things that I saw when I was a little kid that were just science fiction and completely impossible. They're all now absolutely possible. And in fact, many of the things that nobody ever imagined on Star Trek and on the rest of it have come to reality. I mean, our cell phones, there's my cell phone charging wirelessly, and soon they're talking about wireless power, where it won't be that you put it on a device, but actually it'll charge through the air, which terrifies me, but I'm sure someone somewhere will work out how that's going to happen without frying us all to death with microwaves. But this device here is the Star Trek communicator, and you mentioned earlier on that TVs are becoming more like computers. Well, I remember when the iPhone Touch came out, the iPod Touch, sorry, not the iPhone Touch, the iPod Touch. And it was very basic, but they had got some apps on there. And I looked at this device, and I was working for a company that wrote dental software at the time. And I said to the guy who owned the business, this changes absolutely everything, because what I had in my hand, and it was smaller and thinner, but what I had in my hand all of a sudden was a handheld computer that was useful. I'd had a Sharp Zorus before, which was a handheld device that ran Linux or Unix or something like Sharp Unix, I think. But the iPod Touch, as it was it had a very good quality touch screen. It ran apps, and it could communicate via Wi-Fi later on. I think initially it couldn't, but now this phone is almost at the point where it can communicate across the internet with the IoT devices, and I can turn my lights on and off. My father-in-law has his front door, his garage, it's got an electric door. He was driving with me the other day to visit my new house. It's like a 45-minute drive from here, and he's like, "Oh, I don't know whether I locked my garage door." So he gets out his phone, presses a couple of buttons, and goes, "Oh no, it's locked." So it wasn't just that he was going to up and, like a remote control, press the button so that it would go up and down, and close. It was that he was able to tell whether the garage door was open or shut. And he has other things as well. Because he has like a heart issue, he has like a little medallion that hangs around his neck. And he can press the button if he falls over. He's getting older, If he falls over, he can press the button, and that will also work in the house to call, medical assistance and panic everybody in the family that something's wrong with him when he accidentally leaves it behind, which he does from time to time. But this is the brave new world that I remember in the 80s as a programmer, thinking, I cannot, I wish all this stuff existed. I really wish it did, but it will never happen. This is all science fiction. Look at Star Trek, that's nonsense. And now it's happened. Now, you there, Miguel, are showing it happening for real. Jim, Mr. Swipe to Unlock, came up with the idea of swiping to unlock with some colleagues I know, but basically you did it. And now we have these devices up in our hands that will do absolutely everything you could ever want. I, for one, it's an exciting time to be a programmer. People go to me, "Oh, you're always so enthusiastic. You're always so upbeat. Why not? Look at the times we live in. Look at the times we live in. Of course, you should be excited about your job. It's a moving target. I am as happy today to be a programmer as I was 30 odd years ago when I first started, and I don't think it's going to go away. If anything, it's a moving target that I'm always going to keep learning. And as long as this bit keeps up, then I should be all right. It's my 10 pence worth on that, or 10 cents worth.
My son is 20 years old. I don't know. They keep getting older. Anyway, I was talking about some of the stuff going on with coming with Neuralink and other transhumanist, augmentations and stuff like that. And he's like, he wants nothing to do with it. And I'm like, I'm excited about it. And he's like, we're in the wrong generation. we're like swap, because he is not a technology person, but I am. So everything's exciting.
It's bizarre, isn't it? My daughter is a definite geek. So she has an apartment down at university, college, depending on whether you're British or American, but she's down at college, and it's like a shrine to technology. She's a streamer and a gamer, but she has absolutely, it's all in pink as well, which is terrifyingly bright. But yeah, that's good.
That would be awesome. I need more LED.
She has cat ears that, I mean, you have the Delphi helmet, of course, but she has these cat ears that they're Razer ones. There you go. See, you're going to put your cat ears on. She has a Razer headset that's got the little cat ears on, and it has a LED that I think it lights up in time with the game that she's playing. She mains Diva, for those that know these things, and she plays Overwatch. I have no idea what that is. Oh, look at that. See, that's just uber geek. Jim, you're always the bigger geek than the rest of us. That's the amazing. Miguel is like the genius kind of Internet of Things guy, and there's us two. We go, hey, cool, LED sunglasses. We know which side of the fence we lay on.
So I don't know if I shared this story on here, but I don't think I have. When my wife and I went to the same high school, but we were separated by a year. We actually didn't know each other in school, but I ran a BBS and went by the handle Cybermancer, and my BBS was Cyberspace BBS, and which that really sets my age for anybody that wants to do the math. But anyway, after we got married, she ran into a friend from school, and she's like talking to him. They're like, "How you doing?" She's like, "Oh, I got married." I'm like, "Oh yeah, who'd you marry?" She's like, "I married Jim McKeeth." And like, "Oh, that name's familiar. Where did I knew that name from?" And then they're like, after a few minutes, wait, Cybermancer? And she's like, "Oh yeah." Oh my goodness, very stuff.
Do you know that for people that follow the elections over here, in Texas, Ted Cruz, our senator, nearly lost to a guy called Beto O'Rourke, which is a huge thing over here that Ted Cruz, in a very, I don't want to talk politics too much, but it's very, very conservative state, and Ted Cruz nearly lost to him. But the interesting thing about Beto O'Rourke is not the fact that he's a politician. It's the fact that, first of all, he's a web designer and a programmer. So if he'd got in to be the senator for Texas, we would have had a guy who's one of us in there. But more importantly, he used to be a member of the Cult of the Dead Cow. He was a hacker, and he had the handle Psychedelic Warlord. That was his handle, a Rainbow Psychedelic Warlord or something like that. Can you imagine someone in the Senate who actually understood how the internet works? And you know, you can just see it now where they have the Senate inquiry, and Mark Zuckerberg's trying to flannel them and going, "Well, that's not a question I can answer." And Beto O'Rourke goes, "Well, hang on a minute." Tears strips off of it. That's what we needed. We needed the government run by the hackers. I think that would have been quite an interesting time. Yes, funny old world we live in, isn't it?
Yeah. You know, the stereotype is that you know, you have to get your kids to help you with technology, but fortunately, that's something my kids have never gotten the opportunity to do.
Did you see that Davey Dye said he had to leave because his coffee maker was telling him it was time to go?
I did not see that, but
yeah, he said, "Sorry, I've got to leave. My coffee maker says it's time to go. It misses me." Bless him.
Yeah, I saw that James just put in a object here so we can make our own coffee. So thanks, James, for that little Delphi code for there. We're actually getting up here at the top of the hour. Probably got to wrap up here.
Oh no, that means I've got to carry on packing to move, Jim.
So anyway, thank you for everybody's coming out here and joining us for this. Miguel, thanks for all the great slides and details and demos and stuff. That was awesome. So much good stuff. Hopefully you got everybody's questions answered, or at least discussed.
Hope so.
And the whole idea, Jim, is I understand that that's why I have to spend a little time, because to many Delphi developers, they don't see this whole separate world of the microcontroller and embedded world. But it's very interesting, and I'm an enthusiast dreaming that one day we can have micro Delphi. If someone develop MicroPython, why not? I mean, I know it's depends on a lot of things, but why not?
Well, there's a Python GUI, and it's written in Delphi.
There is Python.
Yeah, there is Python GUI. It's worth checking out and a lot of the demos on the blog site on the Embarcadero, blogs.embarcadero.com. If you search for MQTT and a lot of the AI stuff that's happening at the moment, you'll find many of those demos, that is particularly the ones that are calling things like Google libraries to recognize text in images and stuff like that. A lot of them are written in Python, with the Python GUI is controlling that application, and it's Delphi. It's a Delphi program. So yeah, it's always fun.
Yeah. No, thanks, Miguel, because that's one of the goals for this, is that I'm trying to pick topics that are maybe slightly beyond what the usual stuff we talk about, just so we can expand the conversation, as it were.
Yeah. And just because Delphi is not running on these microcontrollers doesn't mean that you cannot run an IoT device. In other words, you even showed it a few years ago. You can have a Pi with an Android distribution installed on it. Delphi will compile to it. So you can have an IoT device with Delphi if you go that step that is maybe not so streamlined, but is definitely possible, that you can have a Pi with an Android distribution installed on it. You can have Delphi there. And best of all, our own smartphones. Our own smartphones are also part of the IoT ecosystem. And to that extent, Delphi already compiles to them. One of the areas mentioned, yes, there is a very robust, most of the libraries for MQTT are open source, but there is one that I have used and it's really robust because it's supported professionally, is the one from TMS Software. So if you have already a subscription with them, I would go with them. If not, then yeah, you can try the open source ones. The problem is, as you know, with open source, you rely on the developers if they have time to support it.
Exactly. Thumbs up from me for TMS as well, but I'm biased. Our friends work there. Great products, and they've mentioned /n software, ECSG, I think, however they pronounce their website. They're also got some components as well. I think we'll try and make sure there's some links put up so that people.
So I did put the slides in the handout section, and there are some links in the slides there as well. So.
Oh, good. Yeah, I put a load in, I think so. Okay.
And we'll continue to have blog posts and stuff more on blogs.embarcadero.com. Oh, you're welcome, Greg. He said, thank you for the inspiring webinar with demos and good humor. That is the goal.
Don't take life too seriously. That's my #1 advice. You'll live longer and you'll be happier whilst you do it.
And Chris says, desk view 386 multitasker running BBSs. Yep, that was the days. I remember that. The desk. I never ran desk view 386. I think I was running my BBS on a XT. Yeah,
my wife had her own BBS as well. She's a proper geek.
Oh wow.
Yeah, I know. I'm in trouble. I can never, schmooze the technology. She knows it.
So there's if you're like the old days of tech, there's a TV show on, you can watch it on Netflix, at least here in the US, called Halt and Catch Fire. It's a drama, historical. It's not historically accurate, but they go through a lot of the big events that happened way back in the early days of tech. It starts with a company that's reverse engineering IBM's BIOS and to make a fully compatible PC clone, which actually happened.
It's loosely based on history.
Yeah, loosely based on history. But one of the things, your comment though about your wife running the VBS, is I remember there was a hard disk crash, and one of the engineers' wife comes in to help recover the data, and all the other engineers were like, "Oh yeah, what's she doing here? She can't." And she's like, "Well, I did my master's thesis and da 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 da," and they're like, "Oh." And they look to her husband and they go, "I think she's smarter than you." And it's like, "Yeah, I knew that. That's why I called her."
Yeah. She's and it was weirdly enough they were based in Texas as well. Because I don't quite understand why that was, but I'm just going to put the link up to that series if people want to watch it, because it is a very good series. Why is my link not working? Oh, typical. Okay, well, maybe I can't put the link up to that. I'll do it another time. Oh, yes, I can. Hang on.
Look in the chat window.
Yeah, that's what I'm trying to do. Hang on. Send to all entire audience. Hopefully that worked. Yes, there you go. It worked. Excellent series, and it's not safe for work. Put it that way. So I wouldn't stream it at work, but there's some interesting scenes in there. But all of the reverse engineering of the BIOS is absolutely true, based on what went on at that time with the black box reverse engineering of the IBM BIOS that happened. And watching that series, if you're old enough, it's like looking back through your younger years in development, because they have got it very, very accurate. I worked in a few startups, and I worked in a few big organizations that were actually at the cutting edge like that, and that's what it was like. It was absolutely like that. Great series.
So I see who it was. Nicholas asked if someone can upload an Android app to the Play Store so we can set the LED colors on my shades. So these aren't Bluetooth, but I do have some other ones that actually I have another. I gotta find them that I bought that aren't they weren't Bluetooth, but they were Arduino Micro based. And so I soldered a Bluetooth module onto it so that I could connect to it over Bluetooth. I'll find those, and maybe we can do that, and I'll hook them up so you guys can connect to the internet or something.
We must mention Boyan Mitov as well, by the way, whilst we're at it. Mitov, M-I-T-O-V. Boyan is definitely, he's a great guy, really, really nice guy, MVP, technology partner, I think, as well, and has many, many components for this kind of stuff. And definitely is worth a visit if people haven't come across him before. But Boyan Mitov,
yes, absolutely. I had meant to talk about his stuff, but then totally spaced it. I was hoping he could join us today, but wasn't able to. But anyway, yeah, mitov.com. He's got also, if you're new to Arduino, check out his Visuino. It's a visual studio or visual platform for developing Arduino applications, and you just connect wires. It's pretty powerful, and there's a lot of examples and stuff out there for it. Highly recommend it. Definitely check that out. Great stuff. I remember doing when we did a webinar with him, and he announced Visuino on this webinar, was showing it off, and was talking about it, and he mentions the price of $9.99 or something like that. I can't remember what it was exactly. In my mind, I was thinking $999, $1,000. I'm like, that's reasonable for this. And then later he mentions $9.99, and I'm like,
put your price up, dude. That's way too cheap.
I went and bought it immediately. I was just like, I must have this.
Really great components. Got a broad range of things that it can do. And if you're into Arduino, and I wanted to do an article. I really forgot about this, and we should finish soon. But I wanted to. I looked through Amazon to get a robot hand. Okay, and I was trying to get, because you can get them that have got these motors in, so you can make them do this. And then I wanted to have a robot face, so it would be like a head, something like that. And so I could say, talk to the hand, but the face isn't listening. I thought it was just such a great joke, but unfortunately, I couldn't order the robot hand, but it would have been such a great, very expensive joke, but it would have been quite funny. So there you go. Talk to the hand.
Yeah, so definitely go check out. Dieter said, glad you finally mentioned Boyan. I feel terrible. I really should have just put a slide at the very beginning that said, go to mitov.com.
I know, right? I'm glad I remembered.
Yes, thank you. And as pointed out, yes, there's free Pascal for other platforms and stuff as well. So that's a good opportunity for Micro Delphi. Okay, all right. Thank you so much, everybody. And we will see you all next week with data visualizations revisualized. Actually, I can share the slides here.
That's me again, isn't it? Sorry, everybody. I'll be back. I'll be back again soon. I keep saying to people, if you don't recognize my face by now, you've not been paying attention.
Yeah. All right. So data visualizations, revisualize next week on June 16th. See you all then. Take care.
See you.
Bye.
Bye.